All right, welcome to Many Relationships. I kind of want to come up with some objectives with this collaboratively. So first, let's figure out where we're at. For the next 3 minutes, I would like you to write down everything you know about many relationships. Doesn't need to be organized. Blah, brain dump it. 3 minutes. Get your writing stuff out. Be on paper, can be on a whiteboard, can be on a computer, I don't give a shit. 3 minutes. Starting right. Meow. You can talk about the concept, you can talk about how you might implement it in Ruby. Things that give you some indication that that's the kind of relationship it is. All that stuff's fair game. All right, pencils, real and virtual down. What I'd like you to do now is share your brain dump with someone else. 2, 2, 2, 2, 2, 2. Just take a minute and share what you wrote down. Go.
Yeah, I kind of read that one.
And it's actually a really good way to at all. Something that I might add as a way of
Within the object.
so that many different relationships can break down into two one-to-many relationships. So if you use an object in
It's kind of hard to put it into words.
I know. You have to put in some code.
Yeah. One to many.
I was just trying to regurgitate what I was learning last night.
Yeah.
Another 30 seconds?
So, it's really whichever relationship you can take, there's a way to take like an array.
No, I'm just like curious what made you buy it.
Yeah.
Value one.
Did you actually do it?
Gotcha.
That's
So,
you finished it? Did you watch the video?
No. It's 11.
You can take this. Basically, anything I said was put these as arguments. All these things we call parts. Initialize function, and then you can make it to your keyword is a variable name, and then value.
Yeah.
Why do you do M:(n) instead of M?
Value one is like the.
We'll talk about that.
So,
I like that.
how will you initialize?
All right, let's get back together.
Oh wait, no.
Cool. So would anybody like to share their answer? Yeah.
Many to many needs a join table, add a reader, turns initializations into methods. The join table is what connects the many to many. Self is the instance we're calling the method on. Hashtag means an instance method, and dot self means a class method.
Love it. Lots of good stuff in there. Who can add something to this? Yeah.
That it's basically just two one-to-many relationships,
Yes. Love it.
and then as many objects can only access other as many objects through the join table.
Yes. Accessing through a join table. Anything else we can add to this? Yeah.
I would add another what Todd said, like I look at it as like an ERD always, it's like if you have two crow's feet on like both sides, you have to have that join table.
Mhm.
And that's like accessing it through the join, where it's like, the single side, the little line, and then join, vice versa, yeah.
Love it. What else? Yeah.
You should instantiate the join table last, so that you should create the instant variables for the other classes, the many classes first.
Love it. What else? Anything else we can add to this?
You can instantiate a bunch of variables using each loop, each enumerable.
Oh yeah, we can enumerate through a lot of this stuff.
But I don't think we actually ever covered. There's just something like that.
Cool. Anything else we can add to this? It's a pretty good list. Denise asks, why M and N rather than M and M? Any guesses? Very nice. That was good. I like that. Let me use that. What else?
Is it kind of a default for like whatever number?
Not necessarily. It's a math thing. Yeah.
The end time, so it could be like one, at least once, but it can join more than once.
Ooh, that's a good guess. Not quite. Yeah.
There could be an amount of different objects or different classes, like
So-
the N.
also a super good guess. It's simpler than that. It's just that if I said M and M, in math, I'm saying it's the same thing. It's not, it's a different table. And so I just increment in the alphabet to the next thing to indicate that these are two different things that are joining. It was the same letter, we're referring to the same thing, but we're not. Cool. What else? It's a pretty good list. Awesome. So I think I'd like to do a couple things. I would like to be able to identify situations that require a many-to-many, kind of build up our intuition a little bit. And then you guys give me some objectives. What do you need more help with?
Like, are there any pro tips on how to determine what you're going to put
Sure. So we'll say like decide which methods go where. I don't know if I like the language on my objective there, but we'll roll with it. What else? Yeah.
Brought up like the library one, right? I
Mm.
would make sense. Is it like possible to have like a many to many and then like right after that another many? And like therefore like
Yes, yes there is. In fact, if we take that, so this is, a many to many is just two one to manys. This is also just an entity. So we can also do joins on that. What? What else? Yeah.
I'm still a little unclear on like self.
Okay. So, ID correct usage of self. What else? What else do you need more?
Is self useful like outside of like classes?
No, not outside of classes. It is like innately a part of classes and objects. You wouldn't use them outside of that, but it's not just a Ruby thing. This is all over the place. What else? Mm-hmm.
I'm kind of scared to ask because I think the answer might be really obvious, but
Uh-huh.
I can totally get this. But I know that this is how we do it. We do it through a joint table, but I'd like to know why we cannot establish many-to-many relationships, like what that screws up later.
Love it. And actually, let's start there. Why joins, and then we'll work down the rest of this. So, all right, I'm going to build something from scratch. If I look in this new folder I made, nothing up this sleeve, nothing up this sleeve. I'm going to make an environment RB file, and then give me a noun to work with. Movie, dog. Let's do dog. So, what's the thing that dog is related to? Owner? Cool. So, what would make that a many-to-many relationship versus a one-to-many relationship? Think to yourself for a sec. Because we could represent that either way. How do we distinguish between those? Katie, what's on your mind?
There's many dogs
Mm-hmm.
that have many owners, and many owners that have many dogs, and they all live in one house, and that's the join. Does that make sense?
I'd say we're about 80% there on that. Can we tighten that up a little bit?
Wait.
What would a one-to-many look like? What would a many-to-many look like with dogs and owners?
Well, one to many would be if a dog could only have one owner.
There we go. So if each dog has one canonical owner, that's one-to-many. And so we say one dog, or sorry,
What does canonical mean?
canonical means like authoritative source of truth.
That just came in the microphone for a second.
Oh yeah, there's a microphone here.
I had no idea that was on. That's
It's-
what I'm on.
It's always on, baby. So this diagram is saying one owner can have many dogs. Each dog only has one owner. Okay?
Can it be implicit if you don't have like the line to represent the one? Or
Yeah, that's if you leave the one off, it is implied, but that means the same thing. But if we want to do it the other way, I have dog and owner. How do I represent this as a many-to-many?
There are multiple owners.
Multiple owners. So each dog can have more than one owner. What are we going to call this join table?
Leash.
Leash? Not quite.
Dog underscore owner.
Yeah, we can call it dog owner. We can call it ownership. But what's happening in this entity here is it's keeping track of every instance of a dog and an owner together. It's another way to look at this. Let's say I have a dog named Bixby and a dog named Mesa. These are IDs and names. And then over here, I have also IDs and names for owner. 1 is Kyle. 2 is Elise. So in this dog owner, what am I doing here? Think to yourself. What does the data end up looking like in there? Volunteer.
Would you join them by the ID?
Yep. Keep going.
No, yes.
It like that's what it is. Yeah.
Dog ID would be like a column and owner ID.
Yep. Dog ID and owner ID. So I have Dodd. Dog ID, owner ID. And now I'm keeping track of every unique instance of a dog ID and an owner ID. So I can say Bixby is owned by Kyle. I can also say that Bixby is owned by Elise. I can't have a third record in here that's also Bixby is owned by Elise. It's the combination of these that we're expecting to be unique in here.
Out of curiosity, what kind of an error would that throw?
It probably wouldn't throw an error. We're not even talking about Ruby at this point. We're talking about data modeling in general. But if we were enforcing that in Ruby, it would be non-unique primary key. No, you didn't. Cool. Ask me some questions about this. This is big. Yeah, Dylan.
Where do we find the IDs? What do those look like in the actual code?
Oh, excellent. So the IDs are generated by the database. You don't put them in. Let your database manage those. But there's supposed to be something that's uniquely identifying each record.
So
Like
so
an
this,
object.
can you clarify?
Like an object ID? Is that?
Not quite. So here's a good analogy. So my name is Kyle. That's not what I am. I'm all these things. I'm a guy who's wearing a vest that his mommy got him for his birthday. I'm a guy wearing dad shoes. I'm loud as fuck. I'm a really good programmer. So like I'm all of these things, but I'm identified by my name. If you go, hey, Kyle, you get all of those things along with it. That's what an ID is. If I have this ID, I can get all the rest of this. And here it's just a name, but it might also be an age and a breed and a color and lots of other things. But I can get any of those if I have the ID.
And that's automatically generated via active record?
That's automatically generated by the database. So in SQLite 3, in Postgres, and whatever database system we're using, I think you guys have been using SQLite 3. They generate this every time you add a new record.
Okay. I haven't used any SQL three.
All right, that's fair enough.
Every time we instantiate a new object, it's getting an ID.
Mm-hmm. Correct. Oh, actually, now I'm remembering. Yeah, we haven't done a whole lot of active record or we're about like, I don't think we've done a ton of SQL stuff either. You can think of this as the object ID then. It works the same way. something that's uniquely identifying the object. If I have the object ID, I can get whatever else that object has. But I gotta have a second dog named Bixby. That's somebody else's Bixby. Different ID.
Is the object ID the thing that shows up inside of the?
The big goofy looking jumble of characters. Yes. Ask me more questions about this.
So do the relationships have their own unique object ID in the join table?
No, they don't. They're not. Well, they're not different than what they are here. So if we're implementing this in Ruby, and I'm keeping track of all these different instances here, these are pointing to like these object IDs over here. They don't get new ones or anything.
So could you say, like, in the code, like, Kyle dot dog underscore ID1, and that will bring back your Bixby or not?
So actually, let's see that. Let's start doing some coding. So you don't have to code along with this, just watch. So dog.rb, owner.rb, dog owner.rb. So at this point, I have these three files. Over in my environment RB, I'm going to bring them all in. So I'll require dog, I'll require owner, I'll require dog owner.
Require is native to Ruby, so you don't need to use any gems when you do that?
Correct. It is part of Ruby. I'm also, while I'm at it, going to require in pry. And then we'll do a binding.pry down at the bottom. And we should be good to go. Actually, these need to be like this. Cool. So over in dog, if I want to make this dog class, how do I get started? It's just got a name at this point. Class keyword, love it. And then capital D dog. And then how does it close? End. As a good programming habit, when you open something up like this, like write the end immediately. So in JavaScript, if you open up a brace, close it immediately. If you open this up and then you do all your work, I promise you, about half the time, you're gonna forget to put the end in.
Does that just make it like tabulate better and stuff?
What do you mean?
Like, does that also make it tabulate correctly?
Oh yeah, it also helps your text editor make this easier to read. But okay, in the dog class, all we have is a name here. What am I typing? Okay, so we can start with a reader for name. If we need to write to it, we can change it to an accessor. What else am I putting in here? Love it. Make an initialize method. What do I need to initialize it with? Got to pass in a name. And then what happens here? At name equals name. Cool. So right now, I should be able to make some dogs. If I go Ruby environment RB, and I go Bixby equals dog.new Bixby. Hey! So there's our unique ID. Tell me some stuff about the object, and I can Bixby.name and get the name back. Sick!
What is the rule of thumb for when we can ignore parentheses?
That's a tricky one. So I would say, when can you ignore parentheses? So if I wrote the same thing with the parentheses, it would look like that. The general rule on parentheses is if it's, how to say this? If there is only one way this code could be presented, you don't need the parentheses. So this versus this, not a big deal. If I needed to group them together somehow, if this could in any way be ambiguous, then we need parentheses. You generally don't in Ruby. There's very few situations where you actually need the parentheses. The same rule applies to hashes, though, and that one gets a little bit trickier because you run into situations where what the start and end of a hash is, that can be ambiguous a lot. So you're probably more likely to use those. Parentheses, you can usually get away with never using. Okay, so I have this dog working out okay. If I go over to owner and just kind of do the same thing. Cool. So I have a dog owner, a dog class, and an owner class. But let's get to this first question. Why joins? So let's say I want to keep track of all of Bixby's owners. I'm going to go over to environment. We can just make some. Say Kyle is owner.new. Kyle. Elise is owner.new. Elise. Bixby is dog.new. Bixby. Mesa is dog.new. Mesa. Okay, so I have these objects now. If I wanted to keep track of the fact that Bixby is owned by Kyle and Elise without using a dog owner class, I want you to think about how I would do that. Think to yourself for a sec. It's possible. It's not a trick question. How would I indicate without this class that Bixby is owned by Kyle and Elise? Think to yourself. Dylan, what do you think?
I think you would have to put Bixby as an attribute for Kyle and
Okay, just Bixby, like I have an adder reader Bixby?
No,
So what is it?
dog.
Yeah, so I keep track of my dogs. So over in owner, I could even pass that in here. So I've got an adder reader now for dogs. I pass in the dogs, and I say dogs is whatever dogs that was given. Also have to do the same thing in dogs. When I make a new dog, I'm keeping track of my owners. Okay? Neat. Let's give it a shot. So now what I want to do is say Kyle owns Bixby as well. Put these down here now. Kyle owns Bixby and Mesa. Elise owns Bixby. Once upon a time. Not to make this all morbid, but those dogs died a very long time ago. But those are my most recent dogs. All right, so I've got these. And, oops, wrong number of arguments and initialize for dog. Ah, I see. So for this, I have to default it to an empty array. Otherwise, it was expecting 2 arguments. I didn't give it 2 arguments. Make sense? Cool. So if I say Kyle.dogs, sick, I got my dogs in there. If I say Elise.dogs, sick. Ooh. I'm gonna have some trouble here though, right? Because if I say Bixby dot owners. But Bixby's owned by Kyle and Elise. How do I square that?
Did you create an owner, attribute in the?
For dogs? Yeah, I'm not passing him in though because, well, I can't pass like Kyle and Elise in here because I haven't defined them yet. I could do that after the fact. So what if I say something like Bixby.owners equals Kyle and Elise. Mesa.owners is Kyle. Cool. What do I need to change over here for that to not throw an error? Need to change it to accessor because I'm changing something. All right. That works. Let's give it a shot. So Kyle.dogs, sick. I got my dogs. Even shows those dogs having us as owners. If I say Bixby.owners, all right. It's got me and Elise. So, all's well and good. Why on earth would I ever need this join table?
Is it because now you have redundant objects?
It's part of it. It's not quite redundant. Yeah. Yeah, if I get a new dog, now there's two places that needs to get updated. I need to update that I own the dog, and I need to update that the dog is owned by me. Uh-oh. So now it's possible for me to own Bixby, but Bixby to not be owned by me. Uh-oh. That's not valid logic in our dog shop world here.
So the dog underscore owner join becomes your single source node.
Exactly. If all of that information is stored here, if I get a new dog, we make the new dog, and then we indicate that I own it. There's only one place that can be. I get rid of a dog, I delete the record in this table.
Yeah, that's a way better way to do it.
That is a way better way to do it. However, it's tricky. So let's figure it out. So, all right, I don't want dog owners. I'm not keeping track of that, of owners and dogs on those individual classes anymore.
Really quick on that,
Mhm.
what you just had, owners equals integrate, is that considered the add at all of that class?
No. What this is, if I don't have that and I only give this one argument, it throws an error. Because it goes, whoa, dog, you said you're going to give me two arguments. If I do that, it goes, if you only give me one, I'm going to set this equal to this. It needs to have the arguments, but you can make a default. Good question. So, all right, we can simplify up those classes. And that also has the added benefit of like a dog and an owner, like who they own, who they're owned by, it's kind of not their business. And as we get more into like application design, that's a thing you keep thinking about. What does this have to know about? If this can not have to know about what dogs it owns, that's better. Okay, so I've cleaned those up a little bit. We go back over to the environment file. We'll get rid of this stuff. Very nice. How am I going to make some use out of this dog owner class? Oops.
You gotta make it a class first.
Okay. Oops, that's right. Womp womp. That's what I get for not writing Ruby for like 5 weeks. Cool, what goes in here?
Initialize it? Is that-
Yeah, let's give it an initialize method. What does it initialize with? Dog and owner. Love it. And then,
Adoption date.
sure, we can put other stuff on there also. I love that. It's a great example of something else we might store in this class. But what else? At dog is dog. At owner is owner. Okay, cool. Yep.
Does the class name need to be the same as your Ruby file name?
No,
Okay.
not a rule. And these are capitals, and this is lowercase and separated by snake case. Even in something like Rails, where the names of things are actually kind of important, it'll translate between those.
Oh, in Rails that matters.
Yep. And we'll talk about why in Mod 2. Awesome. I have this dog owner class now. If I wanted to do the same thing I was doing before and say dog owner dot new, and it was looking for dog and owner, cool. So I just say Bixby, Kyle, Bixby, Elise. Neat. Oh, one other thing that we definitely want to do here, because if I do that, like I don't have any way of accessing these new records. So what else do I need? Need the add at all. I need to keep track of everything that I make. Add at all. What do I initialize it to?
Empty array.
Empty array. And then what do I do? Shovel self. Add at all. Shovel self.
Dot push do the same thing?
Yes, same thing. Actually, I forget. Is it 2 or 1 in Ruby? 2. Wonderful. Thank you. So there's a question when we started this about correct usage of self. Think to yourself, what is self here? I'm gonna call on someone. Matt, what do you think? The instance of dog owner. Since I'm in the process of making a new instance, self refers to the instance that I'm making. So if I want to keep track of all the instances that I make, which is what I'm doing up here, that's what that is. There's exactly one other definition of self, and we're about to do it. If I want to be able to read that add at all, what do I do? Yep. Self.all. And it what does what? Just returns add at all. This refers to something very different. What is this referring to? The class. Why? Why do these mean two different things in these two different uses?
The scope.
Yep.
Where it's being called.
Where it's being called. If it's inside a method, it's referring to the instance. If it's outside of a method, including like as part of the definition of like the name of a method, referring to the class. Real easy. That's not the case in every language. JavaScript has 9 different definitions of what its equivalent thing could be, and they add a couple more every year. It is the single most confusing part of that language. Luckily, not so in Ruby. Only 2 different things that self can mean. What's self?
Where?
Depends on where. Expand.
So, just as we have mentioned before, self within the initialize
Mhm.
method is the instance object that you've created, which you're shoving into an array. And then if you call it within the class, you're calling dog owner dot all, essentially. and then telling it to return the value of that array, or that array in this case.
Love it. Cool. Somebody else. What's self? What is self? That was the right answer. I just want to hear somebody else say it. Yeah.
Yeah, so like when it's like not with the period, like the method, it's like that self is that instance is specifically calling that method. And then when it's like self dot period, it's that whole entire class and the instance, and if you want to use the word instance, would be like dog owner, like the whole category.
Love it. Excellent. So now that we're keeping track of all these dog owners that we make, when I do dog owner, new Bixby, new Kyle, or new Bixby and Kyle, Bixby and Elise, I could do something like dogowner.all and see all those. It's pretty cool. A dogowner.all. Yes, my beautiful dog ownerships. Something I want to call out here. This is something that I see Mod 1 students mess up a lot. So if you're having conceptually a hard time with this, this might be the thing that unblocks you. When I made a new instance on this join table, the things that I passed in were the objects, not like the names or something. So it will do something like that and expect that to work. Doesn't do the same thing. We're passing in instances of the objects. Beautiful. So we've got this all modeled correctly now, but how do I do Kyle.dogs, Elise.dogs? This is our like part of like which methods go where. This is how we're reaching through and going through the class. Yep.
That's when you want to add the outer reader.
Okay.
Because if you write that, then you don't have to write out the methods individually for
Okay.
each variable.
Like that.
Wait, are we in owner?
We're in owner.
Okay, yeah.
Okay, so if I do this, what's it going to be looking for with outer reader?
For dog to be initialized.
Not necessarily initialize. It's going to be looking for an instance variable called dogs. That's exactly the kind of thing that we're trying to get away from. That's what we were doing when we were like keeping track of it, two sources of truth. We have to calculate this a little bit. So if I say def dogs, how do I get this owner's dogs?
You have to use the join table.
Have to use the join table. What you think, Todd?
You have to iterate over the dog owner dot all.
Yes. This is the magic trick. If this has an array of every single dog ownership, this is where all the pieces come together. All those enumerables we were doing, we're going to do some enumerable magic here and try to get only the dog ownerships for this owner. How do we do that? Select. That's how I filter stuff down, right? Cool. What happens in this select? How do I know whether or not
Dog owner dot name is equivalent.
So if I do dog owner dot name,
Or just dog owner object.
yes, because if I do dog owner dot name, that's how we run into this problem. More than one person could be named Kyle. More than one dog could be named Bixby. These unique identifiers. That's the thing that we're looking for. In our case, that's like the object ID for the object or whatever. Okay, so I want one where the dog owner, what?
It's equivalent to self.
Not the ID, is equals self. Dog owner dot owner, thank you.
It won't work though, or I don't think it'll work. We need to have a macro on dog owner for like, to be able to call that method dog owner.
What? This should work.
We don't have an attribute reader.
Because, yeah, I can't call a method that hasn't been defined. All these adder readers are doing is defining methods for us. We don't have an owner method. So I can say adder reader owner, and presumably I also want dog. Very nice. Cool. So now I've filtered down the instances of dog owner where the owner is me. Why is that me? Why is self that instead of the owner class? In a method. It's in a method, it's the instance. Unless, actually one exception to that, unless it's in a what method? Class method. Very nice. Okay, so we'll say this, my dog ownership matches. Great variable name. Okay, so I've got all of my dog ownership matches, but that's not what I want. What do I want?
That dog.
Yeah, I want just the dogs from that. Because if I log this right now, we try running this, Ruby environment, yep. Oh, well, let me run inside of it. It's fine. So if I say Kyle.dogs, uh-oh, I get a matching dog owner class. That also has like me on there and some other shit. I need to transform this into just the dog. How do I transform that? Map, thank you. So I'm going to take this my dog ownership matches and map pro tip. God, come on, man. Whatever your variable that you're mapping over is, this also applies to selects and reduces. Whatever's in like your block variable here, plural, singular, plural, singular. People try to get too clever with coming up with something for this. Plural, singular, always. So my dog ownership match, how am I transforming this?
You just want the dog.
I just want the dog. Just give me the dog. Yeah, dog. Cool.
So then if you don't want it to return in an array,
Mm-hmm.
and you just wanted the dog objects themselves without being an array, do you do like each entry in order, or something like that, to not have it in an array?
So why wouldn't I want it in an array?
If you're like gonna end up, you're gonna pass that through, I don't know, you're right, I don't know.
So the entire conceit of this is that I may have more than one dog.
Right, it needs to be a collection.
So more than one
Yeah.
indicates array. Now, let's say though that I did want to, I only want my first dog. And we'll say my dogs come on in, dummy. So let's say I wanted only my first match. What could I do?
You could dot first your
Mhm.
resulting value,
Yep,
which is an array.
perfect. So if I just bring back whatever the first one is, cool, not in an array.
Right.
Now, I don't like that though. And also, I'm calling it dogs, but I only get one thing back. That's confusing. Also, now this method is doing like more than one thing. I got my dogs, and then I did a separate thing. I could make a first dog method and do something like dogs.first.
Couldn't you do the same with the my dogs, like make a method for that?
Absolutely. The problem is this on its own is meaningless. So there's no reason that we would call that separately.
Okay.
This is only meaningful because of this thing that we do it here. But I might want to get a list of my dogs. I also might want to get my first dog for whatever reason. So that makes sense to put those in different methods.
Well, I feel like we could change now to find somehow and get the first dog.
You totally could. However, now you don't have a list of all the dogs that you could use. The way I've written this here, I can get all of my dogs or I can get my first dog. If I use find here, I never get all of the matches. That's why. Also, pro tip, if you do this, somebody will be impressed. Maybe just your mommy, but maybe your code reviewer. You can also, wait for it. What? And also, at that point, this variable never gets used anymore. What? So that's how you make some tight code. Dylan.
At this point, can't you get rid of dog owner as well? Because it's in the class?
Like that? No, because I don't have a method name all. Dog owner does.
Because you're calling it on an instance.
Yes.
But a class method would not be dog owner.
Say that again?
You had a class method.
Class method where?
I'm just saying.
Oh.
Yeah.
Oh, if it was.
Yes.
Yeah.
Correct. You got it.
Do you know if the API, REST client and APIs, if that's for us at 11?
Russell, yes, that's the new thing.
Okay, cool.
Cool. So one more thing that might save your bacon on your many-to-manys. So I can successfully reach through that class and get my dogs. Nice. This isn't actually enforcing uniqueness. So for example, if some jerk, some dummy dum-dum puts that in there twice, I don't want to get, see, I'm doing this on Kyle. I don't want to get Bixby on there twice, and that's exactly what happens if I run this right now. Kyle.dogs. Bixby! So what can I do there? Dot unique. Love it. That's what it is in Ruby, right? It's spelled all weird. You know why they did that? It's kind of interesting. So most programming languages are like written in English, even if you are not a native English speaker. And spelling that correctly is like, that's a pretty weird, borrowed kind of thing. So for the international audience, this is less like, oh yeah, in English there's this weird kind of rule that they borrowed from French that, yeah, fuck it, it's that.
It's like closer phonetically.
Exactly. So I do that. Kyle.dogs. Now I only have one. Yes. So we can do the exact same thing from the other side, but we have a single source of truth in the middle. That's the cool thing about that. So we have gotten a little bit better at identifying situations that require many-to-many. We saw dogs and owners with each dog has one canonical. We also learned what canonical means. It has one canonical owner. We also explored like what that would look like for a many-to-many. hopefully we're a little bit more confident on which methods go where. In any many-to-many situation, your, like the, well, let's put it this way. In your join method, always need an all. We always need to shovel into all. We always need to make that all method. But otherwise, that's it. That's the only thing that needs, and add at all. The other ones we might want to do, not required. For this reaching through the class, that's what we need there. And then in any of those individual classes, we're trying to make this as much like English as possible. Who are Kyle's dogs? Who are Elise's dogs? And then we're using our enumerable magic to calculate all that. We have ID'd the correct usage of self. Instance. When is self referring to an instance? Inside of a what method? Instance method. When does self refer to class? Inside a class method or anywhere else in the class. Very nice. Cool, so I'm going to call that mission accomplished, mission accomplished, mission accomplished. I have been your pilot, Kyle Corbley. Thank you all very much.